what we're looking at today is lesson 1 from unit 2, so in your new workbooks. So we're looking at unit 2, lesson 1, projecting and scaling. So let's go ahead and jump on in. Okay, so sorting rectangles. Rectangles are made by cutting an 8.5 by 11 inch piece of paper in half again, and so on, as illustrated in the diagrams. Find the lengths of each rectangle and enter them in the appropriate table. So we've got this figure right here. So we've got our 8.5 by 11 sheet of paper. We've got rectangle B here was cut in half. Then we fold that in half again to get C, and then folded in half again to get our D, and then folded in half again to get E. So we've got all these different figures. So some of the rectangles are scaled copies of the full sheet of paper rectangle A. Enter the measurements of those rectangles in the table. Some of the rectangles are not scaled copies of the full sheet of paper. Enter those measurements for the rectangles in this table. So if we look at the ones that are scaled copies of the full sheet, which one do we think are scaled copies? Which ones look like the original but are a smaller size? So hopefully you guys are thinking C and E. This would be true. So the C and E are scaled copies of A, which is the whole figure. So if we think about C, the dimensions of C, so we take our 8.5 by 11 and we cut it in half. So we cut the 11 inches in half to get the dimensions of our B. So B here, 11 divided by 2 would be 5.5, and then it's still by 8.5 here. Now, so we know C, this dimension is 5.5, but our width, so going across, we went from 8.5, but we fold the paper in half, so we have half the size. So 8.5 divided by 2 would be 4.25. So rectangle C, so C is, so for C, we are going to have the length of our short side is going to be the 4.25. Sorry, don't know what happened there. So C is 4.25, and then the long side would be the 5.5 that we found. Now, we already found the dimensions of B, remember? They were 5.5 by 8.5. All right, so now we need to take and look for our other ones. So remember, E, we said, was another one that was a scaled factor or a scaled copy. So we know that the width here total is 4.25, but each together, 2 E's make 4.25. So we need to divide that by 2 again. So if we take 4.25 and divide it by 2, we're going to get 2 1/8. Then take our 5.5. This is split in half. So 5.5 divided by 2 is going to be 2 3/4, which this also helps give us the dimensions of D. We know it's going to be 4.25 by 2 3/4. So for E, which is a scaled copy, we're going to have 2 1/8 by 2 3/4. And for D, sorry about the random weird lines, it's going to be 2 3/4 by 4.25. So for 3, look at the measurements for the rectangles that are scaled copies of the full sheet of paper. What do you notice about the measurements of these rectangles? Look at the measurements that are not scaled copies. What do you notice about these? So what we should notice is that from column to column, the measurements have the same quotient. So A, C, and E. So if we look back up here, A, C, and E, to go from one column to the other, if we divide them, so taking 8.5 divided by 11, 4.25 divided by 5.5, 2 1/8 divided by 2 3/4, the quotient is 17/22. Taking the short side divided by the long side. So this is short divided by long. The same is true down here. If we look, 5½ divided by 8½ and 2 3/4 divided by 4 1/4, it's going to be 11/17. So the quotients are the same. But if we think about it in terms of the whole thing, they're different. So this is why B and D are not scaled copies of A, because their quotient is different between the two sides. All right, for number 4, stack the rectangles that are scaled copies of the full sheet so they all line up at a corner. So notice they're all sharing this corner here and lining up as shown in the diagram. Do the same with the other set of rectangles. On each stack, draw a line from the bottom left corner to the top right corner of the biggest rectangle. What do you notice? So I'm going to do my best at drawing this. Obviously, you guys know I can't do a very perfect straight line through these, but I will try my best. It sort of worked. So I did a lot better on the second one. If we draw a line through these, it should, I know my first one didn't work out quite so nicely, but obviously that's because of computer error, not actual issue. But what we should notice is that this diagonal line goes through each of the vertices in these rectangles. So the diagonal goes through 2 vertices of the rectangle in each pile. So diagonal goes through 2 vertices in each rectangle. So it's going through this bottom one that they all share, and then it should be going through this other corner, the opposite corner. I know in my first one it doesn't exactly line up, but that's not because it doesn't. It's just because of my technical issues of trying to draw on the computer. And in this one, we can see it a little easier. All right, for number 5, stack all the rectangles from largest to smallest so they all line up at a corner. Compare the lines that you drew. Can you tell from the drawn lines which set each rectangle came from? So if we were to put these 2 sets of stacks on top of each other so that we could see all of them piled on top, would we be able to tell, if we had the diagonals, which ones went with which? Yes. Yes, we would be able to. The diagonals of the second set lie above the diagonals of the first one. So, yes, diagonals from second are above diagonals from first. So we'd be able to see which ones go together, because if they are scaled copies, we should be able to draw that diagonal because they are all proportional to one another. So we should be able to have that, okay? So our next thing we're looking at is scaled rectangles. So here's a picture of rectangle R, which has been evenly divided into smaller rectangles. 2 of the smaller rectangles are labeled B and C. Is B a scaled copy of R? If so, what's the scale factor? So we've been talking a lot about scale. Scale is your key word for this lesson. So looking at B, what portion of R is B? It's 1/4. So it's a fourth representing, because there's 4 different ones. So it is, so the length and width. So if we think about each of the lengths and widths, it's cut in half and half again. So we're cutting both those dimensions in half. So yes, scale factor is 1/2. Now, even though it represents a quarter of the whole, its scale factor is just a half because we're cutting each side in half, because we're not looking at area per se, we're looking at lengths here. So is C a scaled copy of B? So in comparison, let's see, we're cutting 1, 2, 3, and 1, 2, 3. So we're cutting each side in by 3 compared to B. So its scale factor would be 1/3. So yes, 1/3. And then is C a scaled copy of R? So is this little c a scaled copy of the whole entire rectangle? Yes. Now, being as we know what the scale factor is to go from C to B, or from B to C, and from R to B, we multiply these two together. So 1/2 times 1/3 equals 1/6. So the scale factor to go from R to C is 1/6. So looking at these different scales and being able to figure out what those scale factors are. All right, if you guys have any questions, feel free to ask. I hope you have a great day. Bye, guys.